Hello students. In this video, we're going to see the tutorial for rational exponents on Edmentum. So I hope this video will help you do the tutorial easily. Okay. So what are we going to learn in this video? So the objective of this lesson is we will study and apply properties of exponents, which we studied in the last lesson, to rational exponents. So there's an introduction here. I would let you to watch it first.
An exponent is a quantity that represents the number of times a real number or expression is multiplied by itself. We typically write such numbers as a raised to n. The real number a is the base, and n is the exponent. For example, in the expression 5 squared, 5 is the base and 2 is the exponent. The exponent 2 represents the number of times the base, 5, is multiplied by itself, 2 times. So, 5 squared equals 5 times 5. You've worked with exponents that are integers. Sometimes, however, you may need to work with expressions in which the exponents are not integers, such as 5 raised to 1/2 or x raised to 3/4. How do you handle exponents that have fractions in them? In this lesson, you'll learn to work with exponents that are fractions or rational exponents.
Okay, so this video just explained how we did the exponents in the previous lesson and how we can apply the same properties of exponents into the rational exponents as well. So before we go on to study how we can handle rational exponents, we need to review the exponents properties. Okay, the properties of exponent. Remember, if you're multiplying two exponents, okay, you're going to add its exponents. If you're multiplying two exponents, you're going to add the powers. So a to the mth power times a to the nth power equals a to the m plus nth power. At the same time, if you have power to a power, like m and n are the powers of the same base a, then you're going to multiply those two powers. So a to the m times n. So you look at this example over here, 2 cubed to the second power. So how do we do this? 3 times 2, you multiply the powers and you get 2 to the 6th power, and the value of the 2 to the 6th power is 64, okay? And a product to a power. So you have two terms or more than one term inside the parentheses, and you have a power on all of them. So what you need to do is to distribute the powers evenly to all the terms inside the parentheses. Like over here, there's an example, 2x to the 4th power. So you're going to distribute 4 and the 4 for 2, the base 2, and for the base x as well. So it becomes 2 to the 4th power times x to the 4th power. So the 2 to the 4th power, the value is 16. So the answer is 16 x to the 4th power. So this is just a review of the properties of exponents. And we continue to do the review as well. Look at this box. Quotient with equal bases. So the bases are the same. Remember, the properties of exponents can be applied only when the bases are the same. Let me go to this previous slide. Look at this. This is A. Everything is A. So this product property can be applied only when the bases are the same. The power to a power property can be applied only the base is the single base. And if there are two bases, also the product to a power can be applied, but not for product of property. Also for the quotient property, okay? Now what do? If there is a division of two exponents, a to the nth power over a to the nth power with same base, you subtract the power, okay? So over here, there's an example, 2 to the fifth power over 2 squared equals 5 minus 2, right? You subtract the power. So that's 2 cubed equals 8, okay? So that's how you do the quotient. I'm just reviewing the properties of exponents. Then quotient to a power, which means we have a fraction with bases at the top and the bottom as well. But the power is common to both the terms. Then you just distribute top and bottom to the numerator and the denominator. Okay, a to the nth power over b to the nth power. And then the final thing is negative exponent. So if you have a negative exponent, do you remember what we do? We just have to switch it to the denominator if it's in the numerator, so it becomes positive. If it's a negative exponent, it becomes positive. If it's a positive exponent, if you switch around from numerator to denominator and vice versa, then the sign of the exponent, which is the power, changes. Over here, you have 2 to the negative 3, and you have 1 over 2 cubed, which is 1 over 8. Why? Because the negative sign changes to a positive. Okay? So these are just review of properties of exponent. And final properties, exponent 0, anything, if you have a power 0 for any base, the answer is invariably 1. Remember, okay? So it could be like, 45ax to the 0 equals 1. 2 to the 0 is 1. Anything to the 0 is 1, okay? An exponent 1, if you don't find an exponent on a certain term, the exponent is understood to be just 1, okay? So don't assume it to be 0 if we do not find an exponent or power on a base. The exponent or the power is understood to be 1. Okay, so let's go to the next one. This is a lesson activity. I would let you do this, but anyway, I'll just quickly go through it. I'm not going to physically do it for you, but I'm going to just explain the things. Okay, so this activity will help you meet these educational goals. What are the goals? You'll make sense of problems and solve them, reason abstractly and quantitatively, and tend to precision. Look for and make use of structure, and look for and express regularity in repeated reasoning. Okay, so let's do the first activity. Read the instructions. Okay, for this self-checked activity, this is not being graded, but it is a self-checked activity. Once you put the answer down on this space, if you click submit, you will see the right answer or the most suitable answer listed down below. Okay, so let's do the part A. Keeping the properties of exponents in mind, to what power must you raise the expression 7 to the 1/2 to get 7 as a result? So now hint, use the property a to the m to the n is a to the mn. Now I have 7 to the 1/2, right? I need to get 7 as a result. I want to just go to the smart notebook and tell you how it's done. So I have 7 to the 1/2. Now I want to get 7 out of it, right? I want to get 7 out of it. How do I do it? How do I do it? The color doesn't change. Okay, I want to get rid of this 2, right? Only then I would get this 7 to the 1, which is going to be 7, right? So in order to do that, I have to multiply or raise to the power 2, right? Raised to the second power. What happens here is it cancels out both the 2's and I get 7 to the first power, and which is 7, right? So that's the question here. So that is why they say use the property a to the m to the nth power. So you're gonna write down here, and then you'll see what answer you're gonna get. Okay, right. Which property of exponents must you apply to the expression p to the 1/2 to derive p as a result? Now, it is similar to the previous question. This is 7 to the 1/2, and this one is going to be p to the 1/2. It's just the just a variable instead of a number. So you should know what you should be using. Okay, that the hint is given in the previous question. So let me check if you can do it. Okay, right. Now the part C. To which power must you raise the expression y to the 1/5 to get y as a result? By now, everybody must know the answer to this, right? To which power should I raise the expression y to the 1/5 to get y as a result? To which power? Think about it. Okay, it's really easy, right? I don't want to tell you the answer. Now, applying the properties of exponents, which mathematical operation changes 2 to the 1/3 to 2? So what is the mathematical operation? Let me go back to the first question. Applying the properties of exponent, which mathematical operation changed this 7 to the 1/2 into 7? What mathematical operation? You see, raising to the second power changed 7 to the 1/2 into 7. So that should be the answer for this one. So here the numbers change, so you need to change accordingly. Okay, and then you are going to, in which other form can you represent the number 2 to the 1/3? Okay, this one I don't expect you to answer correct, because this is what we are going to see in the next slide onwards. But still, I just want to give you a heads up. Any rational exponent, okay, 2 to the 1/3, any rational exponent can be written as a radical. It can be written as a radical. So what is a radical? You should remember that we did radicals in algebra 2. So radical is this one, okay? We call this a square root. Square root, right? So though there is no 2 in it, we just say it is a square root. And then another radical is cube root. When I write the smallest 3 in front of the radical symbol, you call this a cube root. Okay, cube root. And if you write 4 and then the radical sign, that's called fourth root, and so on. Okay, fifth root, sixth root, all. These are all radical symbols. Now, a rational exponent effectively is a radical. Okay, so how do I write the rational exponent as a radical? This can be written as well. So the denominator has 3, which means this is cube root of 2. So this is the root, how we raise the power to a fractional exponent or rational exponent. Okay, so that's how it's written. So that's the hint I'm giving you here. So 2 to the 1/3 can be written as cube root of 2, which you're going to learn elaborately from the next slide onwards. Okay. So you're going to do the self-evaluation, rate your work on a scale of 1 to 5, with a 5 as a highest score. Then write a brief evaluation of your work below. Note what you learned and what challenged you. Okay, so I'm going to stop this video right now, because I don't want this video to be long and boring. So I just want to stop it and then do another video for you.